1997, number 79. Now, let's take a look. This requires you to know this definition of the derivative. So the derivative of f at point x is the limit of f of x plus h minus f of x over h. Now, if you compare this to this, the only difference is you have 2's here instead of x. So therefore, this is actually the derivative at 2. And we're told it equals 5. So we're told the derivative of the function at 2 is 5. Now it's asking, is this function continuous at 2? Well, you should know that the derivative does not exist if a function's not continuous, if the function has a sharp point at that point, or if there's a vertical tangent line. But since the derivative exists, it must be continuous, so that must be true. Now, is f differentiable at 2? Well, if the derivative exists, by definition, that means it's differentiable. Now, this last one is kind of tricky. The derivative of f is continuous at 2. It's not talking about if f is continuous at 2, if the derivative is. All we know, the derivative equals 5. It could be a sharp point, right? If you were to graph the derivative at 2, and this will be the graph of f prime, and there's 5, could it not look like that? Where the derivative at 2 is 5. So if this is the graph of the derivative, f prime, and that's x, so it exists, it equals 2, but the derivative of the derivative does not exist because it's a sharp point. So that's a possibility. So you cannot figure out what's going on here because all you know is the derivative at 2 is 5. So it's going to be 1 and 2 only.